Hello students, this is Dr. N. Venkatachalapathi. I am going to discuss on electron beam welding. What is electron beam welding? What are the concept of electron beam welding and how the main principle involved in that electron beam welding and how the advantages, limitations of the electron beam welding and finally applications of the electron beam welding discussed clearly in this video. Okay, as you know that this electron beam welding, this is a comes under the second unit of manufacturing process. So it is a BTech fourth semester student. We have a manufacturing process in a course. In that course, the student aim to study the various fabrication process. The welding is a secondary process where you can able to study the joining of two similar or dissimilar metals by adding filler without adding filler metal, by application of pressure without application of pressure, etc. So this electron beam welding, one of the most advanced fusion welding process. In general, the welding can be classified into two types. One is a pressure welding, the other one is a fusion welding. So the main intention of this fusion welding process where the electrons are generated through electron beam. So there is a flow of electrons can be generated through an electron gun and accelerated to a very high speed using electrical fields, some of the source of electricity, either DC or AC, and this is a high speed stream of electrons is tightly focused using magnetic fields and applied to the materials to be fabricated or joined. So this is a general principle involved in electron beam welding process. Look at the three-dimensional diagram of electron beam welding. So just let us see what are the various components and the various structure of the construction features of this electron beam welding. Generally, there will be prismatic. There is a prismatic and telescope for viewing and a high voltage cable. There is a red signal is a high voltage cable and incandescent cathode. So there will be a cathode and bias cup, primary anode, and there will be electron beam. So in general, it will passes through the cathode and the first flow of electrons will start slowly and it will be generated more and then again it will be turned into a single point, single focal small point. All the flow of electrons put on the workpiece in a single point. That is called where the weld bead occur in that point so that the two pieces can be joined effectively with the electron beam. Okay, so this is a general concept of the electron beam welding. So technically you can see the electron beam welding is a fusion welding process whereby electrons are generated by an electric gun and accelerated to high speeds. There is even one flow of electron where a high speeds will be generated by using electrical fields. And this high speed stream of electrons are tightly focused in a single focus point by using magnetic fields and applied to the material which has to be joined. So this is what a technical definition of electron beam welding. Even the students also, when you are writing in a that is semester examination, you should draw a line diagram is sufficient, but the only thing is the technical words such as fusion welding process and electrons from generated from the electron gun and high speeds where accelerated, that velocity can be increased to that electrodes by using electric supply. These terminologies were very important and there will be two metal pieces can be joined to magnetic field of this electron beam welding. Okay, and here there will be a vacuum chamber is there and some deflection coil, focusing coil and the beam, the yellow color which indicate this is the electron beam. So that is the high intensity beam will be provided in that workpiece so that it can be joined together effectively. Now let us see the a line diagram where you can able to explain the principle of electron beam welding. So do you know? So this welding works on the same principle of electron beam machining. So we have studied in machining process also. There also this electron beam machining is there. The basic difference between a machining and welding is machining means there you can remove the work pieces. Here the fabrication where you can able to join the two pieces with the focused electrons. This process uses kinetic energy of electrons to produce heat. So this is why the flow of electrons generate kinetic energy, and the kinetic energy of electrons to produce the heat. Due to heat, the focused material can be joined together. So this heat further used to weld two welding plates, either similar or dissimilar plates. When a high jet of electrons strike at a welding plates exactly local point or focus point, it kinetic energy is converted into heat energy. This is a very important concept. In a electron beam welding, the principle is kinetic energy is converted into heat energy. What is by kinetic energy? The flow of electrons. Okay, flow of electron, half mv square velocity, very high force, high speed velocity electrons will transfer to generate a heat. Okay, automatically the heat will be generated, the metals will be joined together effectively. This heat energy is sufficient to fuse two metals plates together to form a weld joint. Very good weld bead joint can be obtained. Okay, so this is what the a basic fundamental definition of this electron beam welding. So this is what majorly we can see the technical terms in the line diagram. So even the previous it is a understanding three-dimensional figure, where this is a line diagram you can easily draw in any examination, internal or external examination. So first one, this is a workpiece, two metal pieces. This is a workpiece 1, this is workpiece 2. Both are separated and can be joined with the electron beam welding, and there will be a deflection coil. So the main purpose of providing deflection coil, in order to that focusing of electron beam should be uniformly will occur at the focal point. If you are not using this deflection coil, that flow of electrons will change the direction. And another important thing is the focusing coil also one should be there so that it cannot enlarge the flow of electrons. If you put the focused coil in between only, when adjusting, the more flow of electrons will come, it can be the width can be enlarged. The very less flow of electrons means width can be shortened. So this is what importance of deflection coil and focusing coil. And obviously you know that there is a cathode, and above that electrode gun. From the electrode gun only it will passes through the cathode, the electrons flow with high velocity. So this is a general technical definition, and the technical terms where you can able to explain clearly, and the concept involved in this electron beam welding is just it kinetic energy is converted into a heat energy. I hope the student can understand clearly this is the principle of electron beam welding rather than this electron beam machining. So machining means different, and here the welding means just process of kinetic energy of the electrons to produce the heat. That is the only the difference. Now let us see the what is the special use of electron beam welding. So look at this is the some of the welding of thick material. So like this thick material also can be fabricated by using of this electron beam welding, because there is no contact of the workpieces, only the flow of beam, flow of high velocity electrons will be touched together to join effectively. So here let us see the besides the ability to weld thick material to thin material, electron beam welding also allows joining of similar or dissimilar metals. Okay, especially here the dissimilar metals are widely used to join or fabricate effectively. Okay, and here one more thing, some combinations which are unweldable by other process are this readily this electron beam is some materials which cannot able to do that, and obviously can able to do for this electro beam welding are most suitable process by using a different unweldable process also can be easily welded by this electron beam welding process. That is why it can be used as a special use of electron beam welding, where the high velocity, high energy flow of electrons will pass through a small opening, and intentionally focused point at that particular point only the heat can be generated so that the joining can be done effectively. Okay, now let us see what is the temperature, how the temperature of electron beam welding occur, how it can be vary, and what is the main intention that the temperature distribution can be explained with the temperature distribution curve. And these also come ANSYS software can be used to generate the what are the temperatures can be vary minimum 1000 to 25,000 degrees centigrade, that we can see clear understanding of the temperature of electron beam weldings. In general, the operation of temperature of electron beam welding as the electrons strike the workpiece. Do you know? As the electrons strike the workpiece, what will happen? Their energy is converted into heat instantly. They're vaporizing the metal under the high pressure. This is what 25,000 degrees centigrade. The temperature is required to get the heat can be generated. This heat penetrates very deeply, making it possible to weld much thicker, especially a thin sections is ordinary welding, arc welding and gas welding can be preferable. Very high thick, so the thick, suppose even some of the what you called some pipes, some large type of electron CRT materials and all that can be most preferable type of method is electron beam welding process. So that is why this is the most widely used method among all other welding process. Look at this temperature distribution curve, how it will be vary. So there will be color indication of navy blue and green, the parrot green and red. So where at the central red only, that can reach more than 20,000, 21, 22, 25,000 degree. At the temperature only, the more heat can be generated, the two metal pieces can be joined effectively, good weld beat can be occur in this process. So this indicates the color indication that blue, parrot green, yellow, and last this the high temperature is 25 degrees centigrade, where that heat only penetrates very deeply, making it possible to weld much thicker sections. Suppose a small thin section can easily join, thicker section means that the flow of beam will be enter inner part also. That is why high thickness parts also can be easily done by this electron beam welding process. Okay, I hope this can understand clearly the temperature of electron beam welding. Now let us see what is the special use of EBM. The special use in the sense where the electron beams are generally in research can be most probably it can be applicable for the advanced technologies, even some medical therapies, even a human being suffered from lot of pains in knee and hand and some heart also, so that traditionally they are using x-rays etc, some image of television screens, oscilloscopes and electron microscope. So the any special type of uses in especially for medical technology, this EBM welding can be most preferable to join effectively. Even our some of the nerves nerving system also can be made this EBM process. And look at in this CRT, that cathode ray tubes, especially in all television screens and all, that CRT is the one of the most vital part where you can able to get the clarity of the picture. Nowadays, all smart TVs, that is LED, LCD screen type of TV has been done, and traditionally this CRT television screens, when any broken and any damage occur, to use this EBM welding technique. Okay, even this SEM. scanning electron microscope, especially this is also one of the main important mission where you can able to test the microstructural components of the anything, any medical, even a human being also. We don't know if any fracture occurs. We don't know exactly what happened in that structure, what happened in that knee. So that if you take a SEM, the microstructure clear indication of any breakage, any crack may be there. That can be done with the advanced technique of EBM or laser beam technology, etc. Okay, that is why it is a very special use of EBM welding is morely medical therapy is the widely used, and also to produce X-rays and images of television screens, oscilloscopes, and electron microscopes also can be widely preferred. Now let us see the another equipments. What are the different type of equipments is required to get the conceptual features of the electron beam welding? So generally, the equipments which are the cathode, electron accelerating system, beam focusing system. The three major equipment where it involved in electron beam welding. Like that, you can see the initially this is called electron gun, okay, cathode, and how that beam this can be explained in this equipments. Obviously the electron gun, if you take an assembly, what are the, if you take the scanning of that electron gun, it occurs like this. Initially the power system, okay, supply system here, and there will be a cylinder, and the cylinder containing of a hot cathode, and there will be a control grid and a pre-accelerating anode. So this is the anode where the electrons will pass through the anode only, and there is a focused anode, and finally electron beam. So initially the electrons will move very high velocity, and it can be tilted to one single focus. So there the two pieces can be joined together. Okay, so that is why it will pass us through the cathode grid only, and before entering to the final point of that electrons, that pre-accelerating anode where you can able to flow can be maintained effectively, so that high speed electrons will be forced together, and there you can able to get exactly one single point with the high temperature, 25,000 degrees centigrade temperature can be generated. The metal piece can be heated effectively. So this is what about specifically the equipment comprises of electron gun. Generally, it generating the electron beam, and another important thing is working chamber. Mostly, it can be evacuated to low to high vacuum, and workpiece manipulator. So the workpiece manipulator is the manipulator where you can able to do the positioning of the mechanism, and another thing is power supply and control. So power supply and control and monitoring electronics. So wherever you go nowadays, lot of fluctuation in power. That is three-phase supply or single-phase supply, and in household power supply, suddenly the voltage can be high and changes due to that system only, that electronic component suddenly it may not work. So that is why for that also you should able to have some controlling technology, controlling method, so that we can able to see the monitoring of all the electronic components are perfectly working or not. So this is what about the major equipment where you can use in the electron beam welding, or cathode electron accelerating system, beam focusing system. Apart from that, electrode gun also one major thing, and working chamber and manipulator, power supply, controller. So this is what about the basic equipments of electron beam welding, where it can be applicable to get good joining of the any type of metals. Okay, now let us see the another thing is advantages of electron beam welding. So far you have understand clearly what is EBM process, and what is the principle involved in EBM, and how the specialty of that methods, and what are the instrumentation. This is called equipments of the EBM process. And coming to these advantages, so nowadays any welding process they should have some merits and demerits. In that even electron beam welding also there will be a few advantages and a few disadvantages also is there. Look at in this diagram also how there will be titanium material, niobium material, and tantalum material. These are the one of the most thick type of material where you can able to perform welding or joining process effectively through the high flow of electron beam will fell into the workpiece. Okay, and the first and foremost thing is the main advantage is thin and thick plate welding. So it is not only thick, we can able to use thin type of also, but depending upon the application, you can able to prefer. You can see the 0 or 1 mm and goes to 300 mm thick also can able to perform this welding process. And another important advantage is extremely narrow seams. So that is thickness breadth ratio 50 is to 1. That ratio also can able to do better. And third most important thing is overall heat input. There is a very low overall heat input, so which leads to low distortion and welding of completely processed components. So we should be able to process processed components. And one more advantage is high welding speed. That is what whenever in the case of electron beam welding, the flow of electrons, you can see the how the flow of electrons cross through the cathode. These electrons will be very high speed. High speed can be generated so that the kinetic energy is converted into a heat energy. So that principle will applicable in this EBM welding process. So that is why here high welding speeds are possible in this case, and there is no shielding gas is required. So that is here there is no workpiece contact will be there. Obviously, there is no shielding gas. If it is arc welding, there is a contact and a shield gas and some loop also it will get, but there is no shielding gas required in this ABM process. And another interesting thing, advantage is high process. EBM is a high process and the efficiency, the plant efficiency will be good. And another last but not least, material dependence. So here also we are preferred for thick plates. When the thick plates means what type of material it is, a ferrous or non-ferrous or any type of other materials also can be preferred. That is what material dependence will be there. First you have to select the which type of material to be processed in this EBM process. Then only we can able to go for the which type of welding method is the EBM is suitable for that, because this high temperature 25,000 degrees centigrade temperature can able to withstand that material. That is why it can often only welding method used where the material dependence can be occurred, such as this got titanium and niobium and tantalum type of material. You can see the in the three-dimensional understanding purpose. So this yellow color and this red color, and where at the red only one small dot. Look at the how the performing of electron beam welding. The two plates are made it, and just by focusing of that beams only, it will join together and. Obviously even a lot of thickness also it will process through inside the materials also. So you can see this how they can able to initially the metals is like that, and when you join together there will be one spark can be occur. So due to that here how we can see flow of electrons will enter through complete workpiece inside the thickness also, then only it may be joined effectively. Some type of welding process only it will touch at the top surfaces only, it cannot enter deep hole. So that is why this is only very thick components can be most preferred in this EBM process. And at the same time, coming to the limitations of this electron beam welding process. So in this Any welding process, there will be advantages and disadvantages. In this case also some of the a few drawbacks. That what is that? Electrical conductivity of material is required. So this is what when you wanted to have a high thickness materials, the electrical conductivity take an important role. So then only can able to suggest. And high cooling rates. Once we have to joining, you should take a more time to cool so that the productivity will be reduces. And whenever the high cooling rate, it may be lead to some cracking will occur. So even you can see in the casting process also, more than 1400 degrees centigrade, that molten metal flow into that mold cavity. Sometimes if it is sudden cooling can be occur, it may be cracks and things may be happen. That leads to a lot of defects of that process also. Even in welding also, you should able to do the preferred cooling rate so that you can eliminate the cracks. Okay, and high precision of seam preparation. So there is a very good quality, the precision. So, as you know that precision and accuracy. So for example, if this is the point, if the target is here means, so this is not a, in this case only you can able to put this is low precision, low accuracy. So like that, wherever you wanted to do the close, different focus will be occur. But here high precision means all the points should come at the single point only. That is why flow of electrons starting with slow, and it will enter, and again it will transfer into a single point. Okay, so like this. So that is why the kinetic energy can be converted to heat energy with the high temperature. At this time more temperature will be there, so that the cooling rate also will be given more in order to have a good quality of welding. And another important point is beam may deflected by magnesium. So when you use that magnesium, that beam may be its slight change. That is why they can use some what you call the detectors. It is not where you can use this deflection coils, and focusing coil can be put for the adjusting of this electrons. Okay, so if you are not having these deflection coils, that may be changed to uneven, so that leads to a the variation in that joining can be occur. So that is why we should take care about doing of that welding. Okay, and another thing, x-ray formation. X-ray formation, that's what all like transparently what is there inside all the material, have you done performed a better joint or not, you can able to check. And size of the workpiece limited by chamber size. This is what another interesting one. The workpiece size should be limited whenever the chamber size will be more. And the high investment cost, even that more flow of electron itself, it leads to a lot of cost that beams producing that electricity also will leads to be lot of setup also, it leads to be high investment. So whenever to reduce the investment, you can use the more number of components, then only this cost can be reduction. Okay, you can see the some dimensional figure how the weld bead can be occur, especially through the electron beam. So you can see the this is gray color is tungsten inert gas welding, green is metal inert gas welding. Okay, and exactly this red color only electron beam. Even that very slow narrow type of joining also will be occurred, that will be very high strength, no need to have some extra material can be come out. Okay, that is why this is a very good quality joint, and we should able to take care how we'll perform this. Some experienced welder, some expertise also can be used to perform better in this electron beam welding process. At the same time, in this EBM also some what are the material favorable for electron beam welding process. So material in the sense almost all steels, that is ferrous metals also can be widely used in electron beam welding process. Even you can see this is what how the tungsten and titanium, tungsten, steels and titanium, and even the gold, the material combinations, for example, copper steel and bronze steels, materials also can be easily done through electron beam welding. And the precautions also you should take for the safety of your eyes and hands and body also. Okay, so here the main important thing I would like to tell here, almost of all steel metals can be preferred this EBM process, and especially even some aluminum and its alloys also preferred, magnesium alloys, copper and copper alloys, this titanium and tungsten also. This is the one of the most important method, so that that costly metals can be easily done this EBM process. Even gold, so where you can able to do different type of ornamental structures. Uh, the girls while necklace and the dollars, everything can be done this electron beam welding. We are joining a small size of holes also can be joined together effectively. Okay, and even sometimes ceramic where electrically conductive materials also, this EBM technique can be widely used. Okay, now this is what about the uh, electron beam welding. I hope the student can understand clearly about this electron beam welding process. One of the most important advanced fabrication process, and this is a three-dimensional figure where you can able to understand starting with the cathode and how the flow of electrons in a triangular manner. Again, it is a focused length and to be joined effectively. And this is a basic fundamental principle and a special use of electron beam welding where different dissimilar type of metals also can be joined together effectively. Especially thick material can be preferred this electron beam welding. And this one the temperature 25,000 degrees centigrade. That is why you should do a ANSYS analysis for taking one material, high thickness material, how the variation of the temperature by giving a cooling. And this blue, parrot green and red shows that the red color only very high temperature that can be easily generated by the cooling. And this is a special use type of such as television screens, oscilloscopes, and what you call the SEM, scanning electron microscope. These are the most advanced mission where you can able to do the structural analysis also can be occur in this. After performing welding also you can easily check they can done perform better or not. So lot of that gold ornamental applications also this can be preferred. And there are some equipment such as cathode, electron accelerating system, beam focusing, even electron gun and chambers and power supply, controlling and monitoring electrons also widely used equipments in the system. And these are the following advantages, especially majorly that titanium, tantalum, niobium materials, extremely thick and thin also most can be used to. That thickness to breadth ratio 50:1 preferred, and a high process and plant efficiency is the one most important thing. And finally, say a few disadvantages means size of workpiece is limited. Okay, so that because it is a very high investment, we should be able to identify the material so that wastage of material can be eliminated. And finally, the material favorable is most probably all steels such as tungsten, gold material, and copper, magnesium. These ferrous and non-ferrous metals also can be preferred by this electron beam welding. So that is why this especially material favorable for electron beam welding preferred is that is medical field. It is most widely used, and some gold ornamental applications also widely used. Thank you for this session. Okay, good luck.
Like, share and subscribe. Hit the bell icon for more updates.